We finished B11, so let's now do B12. In B12, they want us to calculate the change in gravitational potential energy. So EGP here, quite straightforward, is delta EGP equal to mg delta H. The m here will be equal to 92 kilograms times by 9.81 times by your height of 1.3 meters. And when you calculate that, it should give you a value of 1,170 joules. Then we move to the next part, 2. So this is B2. The cycle is pattern continuously, so the useful power delivered to bicycle is 75 watts, also known as 75 joules per second. Calculate the useful work done by the cyclist climbing up the slope. So we have to find the work done here. So usually, remember, force is gotten by, or in this case, we just want work done. So remember the equations of power. Power is equal to work done over time, equal to twin of work done is energy over time, as version, force times velocity. So we're going to use work done. Work done is therefore the subject, so it becomes power and time. So here's your power, time is 8 seconds. So work done is equal to power times time. Power is 25 times 8. And hopefully you can calculate this. When I pause the video, it should give you around 600 joules. Some energy is used in overcoming frictional forces. So instead of just moving from kinetic energy, using Foucault kinetic energy to gravitational potential energy, you also will be using some energy to go against frictional forces. Use the answer in B for these values here to show that the total energy converted in overcoming frictional forces is approximately 670 joules. So let's say in C1, your work against friction should be 670 joules. So again, we use Foucault using Foucault, which states that your energy source is equal to your energy use. Your energy source here will be the object moving initially. So you got EK initial, let's put a U here. It will be converted into the final EK, that's why it increases. It is then used to go up slope, so you got EGP, and used against friction. But we have the value here, so let's make WF the subject. So WF is the subject, so you got EKU minus EKF minus your EGP. Again, we have to be careful because when we did this part is actually EK final minus EK initial. So I'm going to rewrite this, make final the first one, so it becomes minus EK final minus EK initial minus your EGP. So it's equal to minus 1240 minus 1240 minus your 1170. But we have a problem because we not only have kinetic energy and gravitational potential energy, we also got the energy that is given by the cyclist, and this is an energy source. You also have the work done that's given by the person to be 600 joules. So we say this is the work done by a cyclist. So it is a plus here, and therefore it is a plus here. Work done by the cyclist plus 600. plus 600 equal to 670 joules. Therefore, shown. Okay, so now we move on to the next component. C2, determine the average magnitude of the frictional forces. So there one frictional force equal to, so what do we use? We use work done is equal to force times displacement. In this case, we're going to work done by the frictional force to be 670. We want to find F. Now we have a problem because we need to find X, the distance moved. In this case, we already measured here, so I'm going to choose a value of around 39 meters, just in between. Okay. So force is equal to work done over displacement. Work done here is your 670 joules. Your displacement S is equal to 39.0. So I hope you can calculate that. Hopefully, when I pause this video, you have a value of around 17 joules. The amount of energy. Oh, careful, this is not joules again. Remember, we're dealing with frictional force. So you're looking at a magnitude of 17 newtons. There is your frictional force. Now we go to D. Suggest why the magnitude of the total resistive force would not be constant. This is assuming everything is exactly the same throughout the thing. So let's write this. Why would the frictional force throughout the journey not be equal to constant? Meaning from time t equal to 0 to t is equal to 8 seconds. Okay. You can already know from the graph, you already know why the force cannot be constant, because notice the velocity actually changes. So, and plus frictional forces come in two types. So here we want to know your frictional force also includes a resistance. Again, what is 670? 670 is taken to be average magnitude of frictional forces. Why is the resistive force not constant? Because instead of just the ground, it also goes against, it also has air resistance. And air resistance decreases with decrease of speed. The more faster you go, your air resistance increases. This is just the opposite. For example, if your speed reduces, your air resistance also decreases. For example, you're standing still here, you're not moving, you experience no air resistance. Once you start walking, you experience air resistance. Imagine you're running, your air resistance will increase. Okay? So I hope you understand this video. It's a bit long, but hopefully you guys can get the gist of all this concept here. The new case here will be this one. Our energy source is 2, the initial energy, and then we power it up again by the cyclist to give more energy so that you can reach a particular height in a faster time. Because sometimes it's actually quite hard to cycle up a slope. And then you got another way to find your force using the work done, and the key fact that frictional force include against the road and air resistance is unique. Basically, the faster you go, the more air resistance you feel. Okay, so I hope you